సో ఇప్పుడు ప్రెసెంట్ 88 అటెండ్ అయ్యారండి. ఓకే వీఆర్ ఇన్ లైవ్. Hello everyone. Hi, good evening to one and all. Welcome to this webinar. Hope you all of us know about APSSDC. So I'm sharing the screen regarding this webinar. So yes, of course, APSSDC is conducting many webinars, so many programs. So please, I think you all of us know. So please follow our Telegram group, social media, and all things. Then you came to know all the things what we are doing. So this is, I think, with collaboration of B.Tech, this is the third webinar. We already completed 2 webinars. So the third webinar regarding understanding IoT, Internet of Things. If you are like B.Tech graduate or any graduate, if you are really wants to know about technology, so this is the best time to learn and to know what to do and what not to do in your life. So yes, of course, today our speaker Sesh Kishore Garu. So he's one of he's a CEO from Singapore. He's having a company which is like SK Deep Tech Private Limited. So he's having like 30 plus years experience in IT industry, and also like his experience like he's mainly master degree in mechanical engineering from Manne State University, USA. So guys, if you have any questions or any suggestions what to learn and how to start your career, you can ask many questions him. Definitely he will help you. And listen today's webinar about IoT. Of course, it's a trending technology in outside, because if you guys are easy electronic and communication engineering, definitely this webinar will use. Not for that branch, other branches also this webinar will use. And of course, if you have questions you can ask. And thank you for giving me to introduce you this webinar and conducting this webinar. So if you guys have any questions and anything, just ask him. Sir, please start the session. Help a student, Andhra students mainly, to learn, because skill is very important. So that's why we are striving always. Please help them to do something. I'll stop sharing screen. You can share your screen, sir, and you can ask.
Okay. Okay. Thank you all for coming for this webinar. My name is KISHORE KOMMAREDDI. I am a CEO of the company SK Deep Tech Private Limited. Today's webinar is about understanding Internet of Things. So I don't go much deep into the technology part. I'll just touch what every non-technical person should know about Internet of Things. Okay. Okay, to give you an introduction of what we do, basically we used to have a company called SK Computers. We are in IT consultancy. In 1994 we started, and later in 2002 I started my Singapore operations, and now we are venturing into deep tech, offering digital transformation solutions to clients. And when we say we deep tech, we are covering all areas like artificial intelligence, big data and analytics, and IoT. So we started in 1994 as a private limited company, and 99 we made it limited. 2002 we started our Singapore operations, and now in 2020 we started 2 companies, one in Hyderabad and one in Visakhapatnam. So we are having 5 brands. One is AI Asia, that's for artificial intelligence chatbot development, and Analytica is our predictive analytics dashboard reports, and Smart Cities is we offer ISO 37120 quality certification for smart cities. And IoTika is our Internet of Things brand, where we offer end-to-end IoT solutions. And Academy is our training division, where we offer deep tech training with industry collaboration. With this introduction, I would like to start today's webinar about Internet of Things. So let's understand what do we mean by Internet of Things. You hear a lot of buzzword, quite often, everybody talks about IoT. IoT is nothing but a network of physical objects that are embedded with sensors, software and internet connectivity to exchange data through internet to other devices or servers. To simply put forth, anything can be connected to internet if we can embed it with one sensor, one software and internet connectivity. If these three things are incorporated in any gadget, we call it IoT gadget, and this gadget will be connected through internet to any other device or to the server. And through server, we can exchange data to any other server, any other medium, wherever you want to exchange. This is what we call Internet of Things. And in fact, anything can be connected nowadays using this technology. Any sensor you can use and any kind of communication medium you can use to connect things. So let's understand what are the types of IoT. When you talk about IoT, you hear a lot of terms like CIoT, IIoT, IMOT, IoE, a lot of buzzwords are there. Let's understand what do we mean by each word. For example, CIoT stands for consumer IoT. That means we refer to Internet of Things in the context of consumer applications like, your refrigerator, your washing machine, your car, or your camera, anything, what normally the things consumers use. If they're connected, then this is called consumer IoT. This is one area or one type of IoT mostly used in what we call is connected homes. All your electrical electronic gadgets inside the home, including your lights, fans, everything can be connected, and this comes under CIoT, consumer IoT. The next thing is IIoT, stands for Industrial Internet of Things. We use smart sensors to enhance manufacturing process. For example, in a manufacturing setting, you'll have a lot of machinery. So we put sensors inside the machinery. For example, you can put maybe a pressure sensor, noise, vibration, or whatever sensors you want to put, you can put inside the machinery, and you can get the real-time data from the machinery, and you can monitor the life of machine, how it is performing, so that it will be useful in predictive maintenance of machinery. This is very useful to monitor the downtime of the machinery. If you see any kind of erratic behavior, immediately you can do some kind of maintenance so that the machine downtime will be minimized. So this is called industrial IoT, where you use all kinds of these IoT sensors and gadgets inside a manufacturing environment, inside an industry. Okay. Another one is IMOT, stands for Internet of Medical Things, or sometimes it is called as Healthcare IoT. Basically, it will be referring to connected infrastructure of medical devices. The best example is your wearable, where this gadget will be monitoring your heart rate, pulse rate, how many steps you have walked, all those things. These all comes under IMOT. So the next one is IoE. Maybe most of you might not have heard about IoE. This term is coined by Cisco, and only Cisco uses this word IoE. So what Cisco thinks is you should think of connecting people, processes, and data to make the whole meaning for the networked connection, so that people, things, and data are connected, interconnected, so that it gives more information and it can create more and more new capabilities. So they have coined this term IoE, Internet of Everything. But unfortunately, most of the people are not using, only Cisco uses this word, and still people use IoT, and mostly you use CIoT and IoT more often. Okay, this is about the types of IoT. And now let's look at how IoT works. So in IoT, the main thing is a gadget. When we say a gadget, inside the gadget, we will have this main thing called sensor. For example, you want to measure any kind of thing you want to measure. For example, you want to measure temperature or pressure or noise or vibration, whatever it is. You put these sensors inside the gadget to collect the data. What data you want to collect? That is the first point. So data collection is done at the gadget level or at the location, exact location where you want to collect the data. And after you collect the data, you transmit the data to a cloud server. Cloud server is where your server is stationed, and you transfer your data to the cloud server. Either you can transfer directly from the gadget to the cloud server, or sometimes you will have, say, for example, 10 gadgets in different locations in one place. So all the data from the gadgets will be connected through a gateway to the cloud server. That means the data will come to the gateway first, and from gateway all the data will be sent to the cloud server. And once the data gets into the cloud server, we do the data processing and do necessary analytics or rule based things, and then we send the data to the destination. The destination could be your computer or your mobile phone or wherever you want to send the data. So this is how in brief the IoT works. Basically, we will have a gadget where we collect the data, sensor data, and send the data to the cloud server, either directly from the gadget to the server or through via a gateway to the cloud server. And in the cloud server, we do the necessary analysis or analytics of the data, do the rule based processing, and then we push the data to the IoT gadget. It could be a compute, it could be to a mobile phone or a computer. Okay, this is in brief how IoT works. So let's look at the IoT architecture. So IoT architecture basically will have four types categories. So the first one is a sensor, or we call it a sensing layer. This is the bottom part of the first layer where the actual sensors will sit and they will collect the data. And then, as I said, the sensor data will be pushed to the gate, which we call a network layer. Where, for example, you have 10 or 20 gadgets. Gadgets will send the data to the gateway first. This is the network layer, and where all the data is gathered, and then it will be pushed to the next level, which is the data processing layer or the processing unit. Usually this processing is done at the cloud server level, where all the data will be sent to the cloud server, where we will process the data at the data processing layer. The data is processed, it will be pushed to the application layer. The application could be your mobile phone or your computer or wherever you want the data to be pushed. So this is the IoT architecture. So we'll have a sensing layer where we collect the data at the ground level, and then we'll have a network layer where all the sensors data or the gadget data will be pushed to the gateway. And the next one is the data processing layer where the actual data will be processed at the cloud level, and then it will be pushed to the application layer, basically to your mobile phone. Okay. Now let's look at each and every component of these four layers. The first one we said is the IoT gadget or the sensing layer. So this is the first part where we will put the gadget where you want to get the actual data from the ground. So this gadget will have mainly three components, which is first one is a sensor. I mean, whatever you want to sense, like pressure, vibration, or whatever you want to sense, you will have a sensor inside the gadget. And the gadget should have a power connection and then internet connectivity. These are the three main components any IoT gadget will have. A sensor to collect the sensor data, power, and then internet connectivity to send the data to the gateway and to the cloud server. So these are the three main components of the IoT gadget. So sensors, as I said, you can have a variety of sensors like pressure, vibration, noise, temperature, humidity. And nowadays, like hundreds of sensors are available. Depending on your application or what type of data you want to collect, you can use your sensor. Sometimes you can combine a combination of sensors also, depending on your application. So the next one is power. Power, you can be an AC power or a DC battery power, or nowadays you can use solar power also. Again, it all depends on your application. And internet connectivity can be Bluetooth, Wi-Fi, or 3G. Any kind of internet connectivity you can use depending on your location and your preferential mode of communication. So these are the main components we'll have inside the IoT gadget. So let's look at the use cases. Use cases is like, okay, where we can use this IoT technology. For example, you can use a light sensor. The light sensor detects intensity of ambient light. So in any location you want to measure the ambient light or the lux, how it is present in the environment, you can use a light sensor, collect the data, and then send the data to the cloud server, where depending on your application you can push the output to your mobile phone. So light sensor is one type of sensor used where you want to measure the intensity of the ambient light. So similarly, proximity sensors. Proximity sensors uses infrared rays. So once they emit the infrared rays strike one object and then bounce back. So we'll calculate the difference in time, and based on that we'll calculate the distance. So proximity sensor is used where you want to calculate the distance from one object to another object. This is one type of sensor. So another sensor is neural sensors. Nowadays these are available where it is possible to understand the neural signs in the brain, infer the state of the brain, and train it for better attention and focus. If you put this the sensor on top of your head, it will sense the signal from the neural signal from the brain, and then it can sense and then send the data to your mobile phone. This is known as neurofeedback, and this is recently people started using this sensor. So there are a lot of other sensors are available. For example, embedded skin patches. These are like monitoring patches. These look like tattoos. They are very thin, very stretchable and disposable and very cheap. Normally, these patches nowadays are used for the patients where they want the patients to wear them for few days to monitor their vital health parameters. So this is one type of embedded skin patch. So these are environmental and chemical sensors. For example, you want to monitor the air pollution, your PMI 2.5 or PMI 10, or you want to measure, how much carbon dioxide is there inside the environment, CO2, oxygen, all kinds of gases you can measure nowadays. So this is like environmental sensors. You can put these sensors inside the gadget and you can get the environment data from live data from the location. So similarly, there are a lot of smart watches and wristbands that are available. What we call them is wearables, where they can sense your pulse rate, heart rate, and like how many steps you walked that day, and all those things can be monitored nowadays. So also in agriculture, like we can use these sensors to control the light control, irrigation control, fan control, and nowadays we are using even to control the temperature, humidity, and even carbon dioxide also. How much carbon dioxide is available in the environment, so that we can monitor how much carbon dioxide is being taken by the plants. So similarly, a lot of IoT gadgets are coming up for healthcare. This is one of the gadgets we are developing under our brand IoTika, where you can sense almost like 16 to 20 vital statistics of humans, especially in the hospital environment. The patient's data can be collected remotely at patient's home, and the data can be sent to the doctor's mobile, so that the doctor can see the live data of the patient and can talk to the patient in through a video call in real time. So a lot of these medical IoT gadgets are being developed using these sensors. So this is about the gadgets. The next step is let's discuss about communication. After we come up with the gadgets, okay, we have the gadget. Inside the gadget we have the sensor, where what type of sensor we want to sense, and then the next step is a communication. So we need to send the sensor data from the gadget somehow to the cloud server. So normally in IoT devices typically connect through IP protocol, Internet Protocol Stack, but the Internet Protocol Stack is very complex and it demands large power and large memory. This is the biggest advantage of this IP stack. And the application layer in Internet is normally HTTP, but HTTP is not suitable for IoT gadgets because HTTP protocol is resource constrained. It needs a lot of power and memory. That's why people have developed a lot of other protocols which are quite frequently used in IoT gadgets. Now let's look at the frequently used protocols in IoT gadgets. The first one is Constrained Application Protocol, or we call COAP. This is one type of protocol. Anyway, if you are not from technical background, if you don't understand all this terminology, just don't worry about it. All you need to understand is there are different protocols that are used to communicate data from gadget to the cloud server level. And this is one type of protocol we use. We call it Constrained Application Protocol, or COAP. Okay, another quite frequently used protocol in IoT gadgets nowadays is MQTT. This is the one you frequently hear anywhere. MQTT stands for Message Queuing Telemetry Transport. This is one type of protocol. This protocol is quite popular because it is a lightweight publication, we call. That means it uses very less power and consumes very less consumption charges. That's why it's getting very popular. And in almost all the gadgets you see nowadays, most of them will use this MQTT protocol. And there are other protocols like, you can use Wi-Fi to connect your gadget to the internet. I mean, if your application is in a home environment, where it's in like an office environment where you are collecting the data and sending to the server, yes, you can use Wi-Fi. Or sometimes another protocol is Zigbee. Zigbee is again a low power consumption protocol, but the disadvantage with Zigbee is it can operate only in a small distance environment, typical like personal networks. It cannot operate more than 100 meters, or bigger environments. This is one type of protocol, but this is again low consumption protocol. So similarly, other protocols are there like Bluetooth and Advanced Message Queuing Protocol, AMQP, and a lot of other protocols nowadays are also being developed by researchers. Okay. And let me talk about LPWAN. This is the latest technology in IoT. LPWAN stands for Low Power Wide Area Network. So to understand, so far we have discussed, to send the data may need lot of power consumption. That is the one disadvantage of using these IoT gadgets. So people started researching about, how to transmit the data using low power and wide area network. Low power means the gadget should use very low power to transmit the data. That is the first challenge. And the next challenge is the availability or the application should access a wide area network. For example, Wi-Fi, it is very cheap because once you have Wi-Fi at home, you can connect any number of gadgets. You might have all seen that. But unfortunately, Wi-Fi is limited to only like to your home. So imagine if you want to have a Wi-Fi in the whole city where you can connect the data wherever you are in the city using low power. That is the technology we are talking about. We call it low power wide area network, where the gadgets can be anywhere in your city, can still be connected using low power using the wide area network technology. So companies have started doing research, and they have done very good research, and they have come up with their own products using this LP-WAN technology. And the two popular products of this LP-WAN technology is one is Sigfox and another one is LoRa. Sigfox and LoRa are the two technologies which use the same concept, low power wide area network. Again, they are commercialized technologies. For example, Sigfox is developed by one company, they branded it as Sigfox, and another one is LoRa, and it's developed by another company, they branded it LoRa. But both follow the same principles of low power wide area network. Again, the advantage, as I said, is it uses low power and it covers a very wide area network in the entire city. But the main disadvantage is, for example, you want to use Sigfox or LoRa in your city, then they need to install this network in your city. That means they need to install these receivers in some other locations in the city, and basically they need to enable the city so that your gadgets can use this LoRa or Sigfox technology. So there is another technology that is becoming quite popular nowadays is what we call NB-IoT. NB-IoT stands for Narrowband Internet of Things. We call Narrowband IoT. So people started using this LoRa and Sigfox because of cost advantages, because as I said, they use less power and they cover wide area network. Then the telecom industry started researching, and they come up with this NB-IoT, Narrowband IoT technology, wherein they will use the existing telecom infrastructure in your city, and then they provide this NB-IoT SIM. So the advantage is you don't have to install another network or another setup in your city. They will use the same existing telecom network. For example, your Jio or Airtel is offering say service in your city. The same network can be used for this NB-IoT technology, and this technology will use very less power and consume very less data. So your telecom provider like Airtel or Jio will give you an NB-IoT SIM, which like an ordinary SIM, you can buy this NB-IoT SIM and you can put this SIM inside your IoT gadget. And using this NB-IoT SIM, your gadget will communicate data to the server, transmit the data to the server, and it will use very less power, and it can be used in anywhere in the city. I mean, basically wherever there is a network is available, this gadget will work. So this is a trendsetter, and people are coming up with lot of new devices because it will consume very less power. Earlier in IoT gadgets, we used to have like a lot of AC power or DC power, and the gadgets are very thick and very big. But because of this NB IoT technology, the gadgets are becoming very thin because, for example, if you talk about power, you can use your ordinary battery, the button battery. You can use the button battery for power and it will last for more than 10 years. And the companies, the way they are charging is NB IoT SIM, they charge per gadget per month. That's how they charge with respect of the usage. And I don't know how they're charging in India, but in Singapore they charge like $1 per gadget per month, which is very cheap. And another advantage of this NB IoT technology is very deep penetration. If you compare this with other technology like LoRa or Sigfox, for example, they don't have tower in your location, then you don't have the connectivity. But Airtel and Jio now they have all over India network, so it's very user friendly and they have a lot of deep penetration. That's the main advantage of this NB IoT. And the deployment is very easy. For example, I come up with a gadget where it uses NB IoT technology. I can buy SIM from either Airtel or Jio, and then I can use that SIM and I'm ready to transmit my data. So this NB IoT technology, because of these advantages, it is making its presence felt, and lot of new gadgets and new things are coming up nowadays. And because the things are coming very small, and it's like a revolution. Every gadget is becoming very small and it consumes very less power and very less internet connectivity. Okay. Now let's talk about platforms. So far we have talked about sensors, and then we talked about the communication, how we transmit the data from the gadget to the server. And now let's talk about the platforms. The platforms means once you get the data to the cloud server, we call it platform. A cloud server is a platform that supports the IoT devices and applications. So once you get the data to the cloud server, here you do the actual processing of the data, and then based on the rules you will process the data, and then you will push the data to your mobile. This processing will be done at the platform level or at the cloud server level. And nowadays, a lot of platforms are available from different companies. For example, from AWS, they have AWS IoT platform. Azure from Microsoft got Azure IoT Hub. IBM Watson, Google Cloud Platform. Lot of platforms are available, and because of the popularity of this Internet of Things, every company is jumping onto this bandwagon and creating their own platforms. For example, Predix platform is from GE, and even SAP and Oracle also have their own IoT platforms. So what you need to understand is platform is the cloud server where you actually do your processing of the data once it is transmitted from the gadget to the server. So let's understand about the future of IoT, how to reduce the cost or gadget size. That is the main challenge what we are facing nowadays. You know, because of this LoRa, NB-IoT, as I said, the communication becoming very cheap, and the power consumption of the gadgets is becoming very less, and people are researching and they're coming up with low powered sensors. These sensors will take very less power. That is very advantage. And because of this nanotechnology, the gadget size is becoming very small, and people are coming up with lot of different applications because the gadget size is very small and uses less power and less costly. And let me talk about a brief thing about fog or edge computing versus cloud computing. This is the mostly when you talk about the IoT literature, you hear this term fog computing, edge computing, and cloud computing. Let me explain you the difference between these three. So, for example, let me explain you with the help of an example of a real world scenario how these gadgets work. Say, for example, I want to use a gadget in my room where I want to measure the temperature in my room, so that, depending on the temperature, I want to switch on my AC. Say, for example, that's my application. So I have developed a gadget where I have put inside one temperature sensor where it will monitor the temperature continuously inside my room. And then, say, for example, I want to switch on the AC if the temperature is above, say, 25 degrees. Okay. So my application is, my requirement is, I want to get a message on my mobile when my room temperature is more than 25 degrees, so that I can switch on my aircon. That is my requirement. So you have developed a gadget, you have put inside a sensor. So in normal practice, what you do is you take the sensor will measure the temperature, and the data will be transmitted to the cloud server. That's what we have discussed, right? So in cloud server, we do the analysis, or we do the rule based analysis. For example, the temperature the gadget sends is, say, 18 degrees. So we'll compare the rule. What is the rule? Is it more than 25? No. So no need to push the data to the mobile. So the gadget will keep on sending the data 18, 19, 20, 22 like that every minute or every 5 minutes depending on your setting. So once the data reaches more than 25, say for example 26, the gadget senses 26 and sends the data 26 to the server, and immediately the server we do the processing, and yes, it's more than 25. Immediately we push the data to the mobile. This is how the whole application works. So if you carefully look at the situation, what is happening is you are collecting the data and then sending the data to the cloud server every minute or every 5 minutes, which is not at all required by the user, right? As a user, I want to know only if it is more than 25, and I don't want the gadget to send the data unnecessarily if it is less than 25, right? So this is where people have started thinking, why unnecessarily push the data to the server, wasting internet cost? Why don't we process at the gadget level itself, and then once it reaches 25 above based on our rule, then it will push the data to the cloud server. So if you look at this scenario, you are pushing the data only once when the data crosses the 25 mark. So if you do the processing at the gadget level, then it is called edge computing. So this is becoming quite popular because of advantages. You can see the advantage. You don't have to unnecessarily push the data all the way to the cloud server and do the analytics at the cloud. It saves a lot of your internet connectivity time and all these things. So if you process the data at the gadget level, it is called edge computing. And sometimes you may want to process the data at the gateway level. Why at gateway level is, for example, my hall is very big and I want to use like maybe like 3 4 gadgets in all other corners of the room and want to measure the temperature in all areas of the room. So these gadgets will collect the data and send to the gateway, and the gateway will collect all the data from the gadgets, and at the gateway, if you want to process the data, we call it is fog computing. So edge computing is if you process the data at the gadget level, and fog computing is if you process the data at the gateway level. And if you want to go back to the old method and you want to process the data at the cloud server itself, then it is called cloud computing. So this is the difference between fog computing, edge computing, and cloud computing. And nowadays people are doing a lot of research, so they want to do a more processing at the edge level itself, at the gadget level itself. Okay. Now let's look at the IoT market. You hear a lot of terms about IoT, and people talk, in future everything will be connected, every gadget will be connected. It is true. In future, everybody will have at least 4 or 5 gadgets that will be connected to the internet, especially because of this advent of NB-IoT and low-powered sensors. Every gadget will be connected to the internet, and people estimate that by 2023, this whole IoT gadget server services market will reach around 300 billion, which proves a lot of opportunity for students, or like a lot of companies will be coming into the market. They will be developing a lot of products, doing a lot of research and coming up with innovative products in various industries where they need a lot of skilled manpower. They want people who have already trained in IoT and who have already familiar with these kind of technologies, like using software, hardware, developing these gadgets, and then developing these total solutions. So there's a huge market that's opening up in the near future, in the few years to come, and every gadget will be connected through internet, and everything will be IoT enabled. So let's look at the what kind of things that connects in everyday industry in your real world environment. In home, every gadget may be connected. Like you will have smart optimized temperature control or optimized use. You can connect your lights, fan, everything you can control through your mobile. Of course, these applications are already started making its presence felt in the Indian market, and there is a huge research is going on. For example, I have seen like one product in the market in Singapore. They say your aircon, they can control it to suit your body temperature, and then it's AI powered, because nowadays AI and IoT are working together. That's why we call it deep tech. Deep tech includes AI, IoT, analytics, cyber security, and all these things. So they're coming up with AI program in the chip level itself inside the aircon. So the aircon detects your presence and it knows, okay, what kind of temperature you need for your body level, and then it will adjust automatically. So you don't have to like change your aircon setting. It will automatically adjust to suit your body temperature. Lot of these innovations are happening and taking place. If you look at the industry scenario, there will be in future machine to machine communication. So the machines don't wait for your intervention to give it an instruction to pass it to the next machine. The machine will talk to the next machine and they will communicate and coordinate with each other, because both the machines are interconnected. And if you look at the automotive, I'm sure you might be hearing a lot about these connected cars, driverless vehicles, and all these things. And I have seen one company they call Here Technologies. This company is being developed by automotive majors in Germany, like Mercedes, BMW, and all these people, Audi, and all these people. So what they want to do is they want to embed all kinds of sensors in your car. So in future, when you buy a car, it will come up with all these IoT sensors embedded, and you will be driving in a highway, and suppose there is a patch in your tire, and immediately you'll get an SMS, because the computer or the software in the cloud server will know that there is a pressure drop in your tire sensor. So immediately you'll get an alert. So what I mean to say is everything will be connected in future and at an unimaginable scale, and everything will be connected, and you will get a lot of personalized information that will help you to better perform. Okay. For example, in agriculture, you can have sensors to identify like leaf wetness, temperature, humidity, and all these things, so that you can better control your crop management. And military, they're using this to have some kind of situational awareness or threat analysis. And in medical is the major area where we are using a lot of IoT gadgets and these wearables, so that you can have a better patient care and better fitness devices or monitoring devices. And IoT gadgets are being used in environmental where you can use a forest fire detection or spices tracking and all those things. And retail, you can use these gadgets in future when you go inside a departmental store. You don't have to wait in a queue or go to the cashier counter to pay. You can just walk into the departmental store, you can collect what you want, you can step out, and automatically the sensors will detect, and automatically the payment will be deducted from your bank account. Lot of things are going to happen, and you see a lot of changes in the real day to day environment. And that's why we see a lot of hope and a lot of opportunities opening up for internet of things area. Okay. With this I'd like to end my presentation, and I would like to take up some questions from the audience.
Yes, guys, if you're having any questions, you can ask. He will help you to solve your questions and everything. And also, I'm sharing feedback. So, if you're having like what you felt regarding this webinar, you can give the feedback. I'm sharing in chat box. And sir, is there any placement opportunity in IoT? I have very good knowledge in IoT and MBA. So, yeah, someone was asked the question.
These questions are posted in the chat box, right? Yeah, I think I can read them. Okay,
Yeah.
the first one is from Om Prakash, Hyderabad. Question is, how much experience or how much deeper knowledge does a fresher need to have to crack an IoT job? Okay, when the IoT companies they start looking people or they're looking for people, what they expect is some kind of knowledge, basic knowledge about these technologies, about sensors, the protocols, and how you transmit the data to the server, and then how you actually do the processing in the server. This is the minimum knowledge they expect. Of course, everybody will ask for experience, but even if you have a little experience of making like one or two gadgets and providing the end-to-end solution in IoT, that's good enough. When I say end-to-end solution, you will be talking about collecting the data, sensor data at the ground level, sending the data to the cloud server, processing the data at cloud, and then pushing the required information to the mobile. This is the whole of IoT life cycle, and this is what people want. Okay.
So guys, if you if you want to ask the question, here we are having a option which is called raise hand. If you raise the hand, yeah, someone was raised the hand. I'm handing the mic. Sohan. So what your question? You can ask the speaker. She will answer.
Thank you. Hello, sir. I'm Sohan.
Yeah.
Sir, I just have a little question about NB-IoT, sir.
Yeah.
Sir, you said that NB-IoT we can choose a SIM from Airtel or Jio, right? No?
Yeah. Correct.
So, which SIM will they give us, sir? 2G, 3G, or 4G?
No, it's 2G. Because
Only 2G, sir.
only 2G, because see, IoT gadget will transmit only data, and they don't need huge capability or capacity. They don't be transmitting any kind of image or voice or anything. It's very
Yeah.
basic data. So that's why they use only 2G, and that's why these companies are coming up with a separate SIM called NB-IoT SIM.
Okay.
Yeah.
Sir, because I've seen a few of them are using also 4G SIMs international wide, sir.
Yeah, because nowadays, I mean, because that is not available till now, because we are using 3G and 4G SIMs. But now, because of NB-IoT, trend is changing now.
Okay. So they're coming back to the 2G SIM cards.
Yeah, they call it
Okay,
IoT
okay.
SIM actually. They don't say 2G,
Okay,
they say
okay.
IoT SIM. Yeah.
Okay, sir. Yeah, thank you.
Okay.
Yeah, guys. Anyone ask the question like raise the hand? You can raise the hand and you can ask the question.
Okay, let me take up another question. When we use IoT technology, we can control the system with a range of Wi-Fi range. So say it is a main drawback. Yeah, that's why Wi-Fi is only like limited capability. You can use only in home environment. That's why NB-IoT is getting popular, because with NB-IoT, if you're connected with a gadget, you can use it anywhere, wherever the network is. Another advantage is NB-IoT consumes less power and less costly. That's why we're using NB-IoT nowadays. Okay. Okay, for ECE, which is the best course? Again, I know when we say B.Tech, we have a lot of courses, analytics, artificial intelligence and IoT, cybersecurity, all these things. every field got its own advantages and every field is expanding. So I cannot say that one field is good or better than other field. It all depends on your interest. Yeah. Another question is, can I get this recorded video of these sessions? I think Haripriya, you need to answer this. I don't know if you send them the recorded session or
Yeah,
not.
yeah, yeah. We'll share the recording sessions like YouTube link. Actually,
Okay.
we kept the YouTube live, so that is the recording session. That's it.
Okay.
Yeah. So in APSSDC channel, all the recording sessions are available. You can check. Otherwise, I'll share to your mails if you registered for this webinar. Definitely, I can share the recording. Yeah, I'm sharing the recording link in chat box, and you can find. And someone was asking about certificate for this all webinars. There is no certificate because it's like a just 1 hour webinar. For 1 hour webinar, we are not providing any certificate.
I think some other people raising the hand. Maybe you can invite
Yeah,
them.
yeah, yeah. Sure, I'll request. I'll hand over the mic. Yeah, Sambasivarao, you can ask the question.
Yeah.
You are telling like we can use this IoT and NIoT something, but under which band they will fall? Like when we use different type of SIM cards, 4G, 5G, and
Yeah.
they are taking back and they are exchanging particular
So,
telecom
no,
company.
this is a new type of SIM card they will give. They will call it an IoT SIM card. I don't know if Jio and Airtel started their operations or not, but that's what I have heard in starting the operations. In Singapore, I think last December, people we have started the operations. So they call it an IoT. They don't say 2G or 3G, but normally it's a 2G.
Sir, but is there any necessary to update? Like generally, if you take any router, we have to update for specific reasons. Is there
Yeah.
any such kind of
No,
things
your gadget
needed?
support basically. For example, if I am manufacturing a gadget, I should make my gadget so that it can take the NB-IoT SIM. So the gadget manufacturer will say which kind of communication this gadget will use, whether Wi-Fi or Zigbee or NB-IoT or whatever.
Okay, and one more thing, I came to know that we can able to produce electricity through Wi-Fi signals itself,
Yeah, it's not
and
Wi-Fi signals, but that is an experiment conducted in Australia. They are quite successful in transmitting through wireless. And now what they want to do is they want to test commercially. Still, what do you call, experiments are going on. But in prototype, they have proven that you can transmit electricity through wireless. Yes.
yes, sir. And what about Li-Fi, sir? Li-Fi, Li-Fi.
Wi-Fi is also people are experimenting that they can transmit internet communication through light through using LED. Again, commercially it is not still out, still
Yes,
at experimental stage. They call it Li-Fi.
sir. You told one sensor they are keeping on human body monitoring. What
Yep.
about the smart blood? Like they will inject one kind of thing inside our human bodies to track our anywhere in the world.
No,
Smart blood.
I haven't heard about that.
Okay, okay. Thank you, sir.
Yeah.
Yeah, yeah. So, any
Okay.
questions you can ask?
Next question.
Is it really
Have you?
happening in India? Small villages by 2025.
I cannot see that. What's the question again?
Uh, I don't. It's not clear. The question was, but another person was asked hand
Okay.
raised the hand, so I'm again handing the mic, which is Kamala sir.
Okay.
So yes, Kamala sir, you can ask the question.
Hello.
Yeah, yeah. Hi, Kamala sir. You can speak out. Are you there? Okay. So
Okay, another question. Are AI,
yeah,
IoT, and robotics good career options for mechanical engineers to pursue a post-graduation course? Yes, of course. When we say industrial IoT, it's all about IoT implementation in a manufacturing environment. That is mainly for mechanical engineers. So earlier, if you look at the manufacturing setting, you used to have a lot of lathe machines and all these things. But in the new manufacturing environment, everything will be robotics, and we call it robotic process automation. Basically, robotics, IoT, and AI will integrate it, and robots will talk to each other, coordinate, and communicate with each other in a manufacturing environment. Yeah.
So again, Sohan was asking some question.
Okay.
Hello,
Yeah, Sohan.
Yeah.
sir. Mechatronic engineering, sir. I'm studying in Canada.
Okay.
Is it good to learn IoT at the early stage, sir? Because I was just started my first year.
No, because see, when we say deep tech or when you go implement a project in real world environment, all these technologies are interconnected. You cannot say this is IoT and all software. Everything is connected and they work hand in hand. All the technologies like AI, IoT, analytics, they are like intermixed now. So it's
Yeah,
always
that's right, sir.
always better to learn because that will be very helpful for you to understand other technology. Yeah.
Yeah, but I also have a previous knowledge about them, sir. About artificial intelligence and IoT.
Okay.
Yes, sir. So is it better right now to learn even more about it?
Yes, because as I said, everything is connected and they expect everything. That's the thing
Yes,
now.
sir. Because mechatronics is a branch which is mixed up of five
Yes,
courses:
yes, yes,
ECE,
yes.
mechanical, computer science, and all.
So the whole of new manufacturing environments will use this mechatronics and everything will be automated nowadays.
Yes, sir. Even I guess mechatronics is also used for robotics.
That's what we call it robotic process automation. That's a
Yes, sir.
new term called RPA, which integrates all these technologies,
Okay,
meaning
okay,
robots and artificial intelligence and IoT and all these things.
okay. Sir, can I please get your contact?
Yeah, I think it's there in the last slide.
Sorry, I couldn't see the slide, sir. You stopped the screen share.
Oh, okay, okay. 1 second. Let me share the screen. Actually, IoTika is our brand. We are building a lot of IoT gadgets under our brand, and we are marketing all over India.
Okay, okay.
Yeah, that's my email ID and phone number.
Sure, sir. Got it.
Of course, our website we are revamping, and it will be up and running from January. All
Okay.
over.
Yes, sir. Thank you.
Yeah. Any other questions?
Yeah, that's it.
I think someone raised their hand. No. Okay.
No, no, no. Okay. So any questions you can really ask. So
No,
we'll end the session as soon as possible.
I think someone raised their hand. Maybe you can check.
Yeah, someone was raised the hand. Yeah, you can ask the question. What's your question?
Yes.
Hello? You can unmute and I think he unmuted, but he was not talking. Okay.
Can control my internet from any place using IoT or not? Yes, of course, you can control that. And a lot of these devices are already available in the market.
Hmm. Okay. So
Okay.
that's it, I think. So any questions, guys?
No,
Within
later you can email me if you have any
yeah,
questions.
yeah. So the last side he's having yeah, yeah. Here having Kishore at the rate
Okay.
skdtech.asi.
Yeah.
So any questions you can email me. Email to Kishore Garu. Definitely he will reply. Yeah, yeah. So I think that's all about the questions.
Yeah.
Still, you can join in WhatsApp groups for future webinars. So we are having like almost 10 webinars. We completed only 3 webinars. So future upcoming webinars, you want any like any information regarding that, just join in that group. So definitely it will help you to join easily for upcoming webinars. So and don't forget to give the feedback link. Definitely by this feedback we'll improve more and more things from our side. So don't forget to give the feedback link.
I think few
So
people
that's it.
raised. Maybe you can check.
Yeah, LKR was what your answer?
Oh,
I
okay.
don't know. Security purpose. He is asking some security purpose. What security? Security is a major concern in IoT. I don't
Yeah.
know what the question.
Yeah, security of course is a major concern, but a lot of protocols are being developed to take care of that nowadays.
Yeah, so that is the question. Yeah. Okay, so for these webinars, there is no certificates, guys. And once again, I'm telling. So 1 hour for 1 hour webinars, we are not providing any certificate. So we'll tell as soon as possible the next webinar date and everything. Will release banner also as soon as possible. So that's it. I hope you enjoyed the session. So definitely we'll come with more webinars and more training programs. And we collaborated with IBM, we collaborated with TechM. So we are doing some crazy programs, crazy trainings for with collaboration of industrial companies. Make use them and yeah, learn something and utilize which is helps to your career. So that's it. And first of all, I would like to thank Kishore Garu for
Yeah, thank you very much.
conducting
And
all
especially
the
thanks to all the participants for patiently listening to my webinar.
yeah,
Thank you. Yeah,
yeah, the SK Deep Tech Private Limited team, the Prashad Garu and Bharati Garu and everyone. So thank you so much for conducting these webinars and helping the students and the PPT, the presentation and everything. The content was really awesome. So thank you so much, sir, for coming and conducting this webinar. We'll meet again next webinar, which is like fourth webinar. So we'll meet and we'll do with the students. Thank you so much, sir.
thank you. Thank you, Paul. Bye.
Yeah, yeah. Thank you, guys. Have a nice day. And don't forget to give feedback.